Let's move to the next property, which is time scaling. Okay, so it says let x of t has x of j omega as the Fourier transform. Okay, then and again I define a new signal as x1 of t, which is nothing but x of at. So this fellow will have x1 of j omega, which is equal to 1 by mod a x of j omega by a as the Fourier transform. So x1 of t, which is equal to x of at. So that fellow will have 1 by mod a x of j omega by a. So means what? So if you do the scaling in time domain, in frequency domain also, the Fourier transform will get scaled. Okay, so we will prove this and then take multiple examples. Okay, note that here we did not put any condition on a. So but in proof, let us take two cases. What are the two possible cases here? So first case is when a is greater than 0. Okay, yes, so we want to find the Fourier transform of x1 of t, which is given by x1 of j omega, and hence we write x1 of j omega equal to integral minus infinity to infinity x1 of t multiplied with e power minus j omega t dt, which is equal to integral minus infinity to infinity x of at multiplied with e power minus j omega t dt. Okay, now we do change of variable. So what is that? So let us assume that we keep at with tau. Okay, so this implies what will happen? Dt would be equal to d tau by a. Correct. So dt would be equal to d tau by a, and we will replace t with tau by a. Okay, so let us substitute these two in the above equation. So what do we get? This implies x1 of j omega is equal to integral minus infinity to infinity. So we replace at with the tau. So you will get x of tau e power minus j omega, and t is replaced with tau by a. Correct, t is replaced with tau by a. dt is sorry, yes. So dt is replaced with d tau, and okay, I'll write this d tau by a. So if you write down this in a nice way, I'll bring a outside because integration is with respect to tau. A is a constant. So this should be integral minus infinity to infinity x of tau. I will rewrite this as e power minus j times omega by a tau multiplied with d tau. So clearly, how is this looking at? The integral is looking like the Fourier transform of x of t, Fourier transform of x of tau, but instead of omega we have x of omega by a. So definitely this should be equal to how much? This is nothing but 1 by a times x of j omega by a. Why? Omega is replaced with omega by a. So what did we get? We got that Fourier transform of x1 of t, which is nothing but x of at is nothing but 1 by a multiplied with x of j omega by a. So we derived this result when a is greater than 0. Okay, we'll take the case what happens if a is less than 0. Okay, so if a is less than 0, again x1 of j omega would be equal to integral minus infinity to infinity x1 of t e power minus j omega t dt, which is equal to integral minus infinity to infinity x of at e power minus j omega t dt. So as usual we will do the change of variables. Okay, so what will happen? Let at equal to tau. Okay, then what will happen? We will get t equal to tau by a, and what else we will happen here? T is replaced with tau by a, and dt will become d tau by a. correct? So dt will become d tau by a. But note that a is negative. Because a is negative, what will happen to the integral limits? T varies from where to where? Minus infinity to infinity. But when t is negative, integral limits will become infinity to minus infinity. So this implies x1 of j omega would be equal to, we'll write integral infinity to minus infinity x of tau e power minus j omega, and tau is t is replaced with tau by a, dt is replaced with d tau by a. Okay, so we will rewrite this as usual. This is 1 by a integral infinity to minus infinity x of tau e power minus j omega times, I will write like this, minus j omega by a tau d tau. Okay, but integral limits are from whatever infinity to minus infinity. So we will do the change of limit. So this will become what? We can write it as 1 by minus a integral minus infinity to infinity x of tau e power minus j omega by a tau d tau. Because a is negative, minus a would become positive. So this should be equal to, I write 1 by minus a. And what is this fellow here? This is again looking like x of j omega by a. Okay, so if a is positive, we get 1 by a, because a is positive, no problem. Here again you have positive value of a. Even if a is negative, what do you get? Even if a is negative, so definitely you will get 1 by minus a, definitely that fellow is positive. So whatever may be the value of a, I mean it can be negative or positive, we should take only the positive value. So that is same as taking modulus, and hence what do we get? We get Fourier transform of x of at to be how much? 1 by mod a x of j omega by a. Okay, so in that way we have proved the result. Okay, and let me write down that here so that it is clear. So this implies x of at will have 1 by mod a x of j omega by a as the Fourier transform. Whatever may be the value of a, the denominator here will have always positive value. Okay.